Okay, let's go ahead and continue on from where we were. So I'm going to just start back to where we just left off. What are some ways in which forces affect objects? Even pushes and pulls are not totally simple. For example, forces always come in pairs. If you push on a tree, nothing happens. If you try to pull on the tree and pull the tree out of the ground, nothing happens. When you push the tree, another force is balancing your push. When you pull the tree, another force is balancing your pull. But where are these other forces coming from? When you push on a tree, the tree pushes back with an equal force. The result is that the forces are balanced and nothing moves. Similarly, when you pull on that big tree, the tree pulls back. This happens for all forces. When the force of Earth's gravity pulls you to the ground pushes up with a force equal to your weight. Forces are not always balanced, however. When forces are unbalanced, something must change. These are the changes that can result from unbalanced forces. So something speeds up, something slows down, something changes the direction of its motion, something changes shape. We can see in these pictures here, so we have this one up here, the wall pushes back on the people. So the forces on the wall are balanced. Let's look at this waterfall here. Because of the force of the gravity, the water speeds up as it falls. So let's go ahead and continue on. So we have here is these changes happen only while the force is acting. Also, while the force is acting, the change keeps increasing. For example, something will keep going faster if a force keeps acting on it. When a rock is falling, the force of gravity is acting on it. Because this force is always acting on the rock goes faster and faster until it hits the ground. When you throw a ball, it speeds up until it leaves your hand. At that point, the force of your hand has no more effect on the ball, and the ball slows down. The ball slows down because the force of friction between the air and the ball acts in the opposite direction of its motion. So where it says try now, we won't be doing this part here where it says how can you explore the effects of force on an object, and it tells you all these different things we will do. We are not doing that. So we can think about what you could possibly do when it comes to the effects of that, but we are not doing this try now. We have other activities or labs we're doing this week so that you can see that visually. So let's continue on. So let's look at this where it says look out. You may think that if an object is motionless, no force are acting on it. In fact, forces act on everything on Earth. Even when you are sitting still on the ground, gravity is pulling you towards Earth. Earth's force pushing against you balances the force of gravity. You are motionless because these forces balance each other. It is easy to ignore the forces of gravity unless we are falling. But it is always present and always the same. Getting technical, how do scales work? The force of your body pushing down on Earth's surface is called your weight. In America, weight is usually measured in pounds on a scale. Many scales measure weight by pushing or pulling on a string or a spring. And our spring right here is what it looks like. So that's what it's dealing with when it's talking about a spring. The spring moves a pointer up or down, which it's going to be right here. It moves up and down. The number of the pointer points to its object's weight. So that's how we can determine smaller items, besides obviously we can step on a scale and we can figure out our weight, but for smaller items, we can put it on there and we can figure out the weight of the items. You may have a bathroom scale that measures weight by compressing or pushing a spring. So we just talked about that. It is easier to understand spring scales by studying a simple scale that stretches or pulls on a spring. You can see these scales at the grocery stores. You can also see them all different places. There is usually one hanging near the fruits and vegetables. I don't think they do the hanging ones anymore. I haven't seen them, but they do have scales on there so that you can place the vegetables and fruit on the scales whenever you do go to the grocery store. And they will give you the weight because they do sell them by pounds sometimes. And so that's why they want, if you need to know how much you're going to get per pound, that's what they'll have the scales for you. Try weighing different things on a spring scale. Notice that sorry guys, notice that when you double the weight, the spring stretches twice as far. 2 apples should weigh about twice as much as one. A quart of milk should weigh about twice as much as a pint. Which force are you noticing that causes these changes? So we got to really think about that of the different things that we've already, if we have one item, 2 items should be weighing more than that one item, like we were talking about the apple. So let's continue on. So we're going to reflect over everything that we just learned. Think back to the broken vase at the beginning of this lesson. Do you think the boy broke the vase? If he did, what force could have been involved? If he didn't, what force could have been involved? What one force must have been involved no matter what happened? So you got to think about that we have different forces that happen. And what we're going to be doing. We're not going to do this next page, so we are stopping right here on this page. That's on page 30. So, what you're going to go in teams and do your forms. You're going to answer that question, and then, you will be done for today for science class. I hope you'll all have a great day, and I will definitely see y'all tomorrow. Bye, guys.